Can a person see the curvature of earth standing on the earth? What formula we brought in? The formula we brought in is, if this is the cross section of the earth and it is a circular region, then a person is standing on Himalaya, on Mount Everest, and then being this is the radius of the earth, and then that person is seeing somewhere on the surface. Okay, so person is seeing from the Himalaya, Mount Everest. Now he is seeing on the surface. Okay, if this distance is d, if this distance is d, then can he see the curve of the earth curvature? That is the question. Can he see the curve of the earth curvature? Now, if person is not standing on Mount Everest, then he see merely 2 to 3 miles away or 4 to 5 kilometers away only. Okay, then can he see the curvature of the earth? He cannot see. Why he cannot see is the if person is like this and he is seeing very near. If person is like this, person is like this and he is seeing very near, then this distance he makes a theta angle from the center. If this theta angle is very small, then he cannot see the curvature of the earth. What is the theta that is required to see the curvature? That is the question mark that we are seeing. If person is seeing 4 kilometers, then from center of the earth, okay, if this is the center of the earth and person is standing here and he is seeing earth like this, then his eye is hitting here. Then this is the person here, it is hitting the eye. There is a theta angle here. This theta angle should be how much minimum that he should see the curvature. That is the question. Now, what is the equation of the distance d that we have seen? If this is the person height is h, this is person height is h, and then he is seeing earth curvature like this. Then if this is d and this is h, and then this arc is s, and this is the radius of the earth, then when he is seeing here, then this is again radius of the earth, and this is 90 degree. I mean, this is 90 degree. This is 90 degree. This is radius of the earth. This is distance he is seeing. Person is standing here. Then this is h. Then this is again r. This is r. This is r. This is 90 degree. Then this, where a person is standing, this angle is theta, and this arc is s, d. So s, this d and s we take similar point because he cannot see much. If that is the case, if this is theta, then cos theta equal to base into hypotenuse, base by hypotenuse, or the base by cos theta. If this is the theta, then cos theta equal to base by that is r by r plus h, r by r plus h. So theta equal to cos inverse r by r plus h. If theta is like that, then r theta is the arc. If this angle is theta, then this is the arc s. So if theta equal to cos inverse r by r plus h, then r theta equal to r into cos inverse r by r plus h. R theta is s equal to r into cos inverse r by r plus h. Okay, this is the way we can say what is the arc. Or if I want to calculate d, then this hypotenuse, that is r plus h whole square minus r square equal to d square. So d equal to a square root of d equal to a square root of r square, r plus h whole square minus r square, that is h square plus 2rh square root. Okay, h we can take as 0 because it is nothing in comparison to capital R, that is radius of circle. So d equal to a square root of 2 into r into h. Okay, so we have so many calculations that we will talk about, and we will see that person standing on Mount Everest, he can really see the curvature of earth or not. We have photographs. So We have photograph means I have not visited Mount Everest. I have taken the photograph. Photographs are available. Anyway, what are the equation that we have seen that S, the curvature, if person is standing and looking down, and then the curvature what he is covering, it is S. If it is looking down, the distance is D. Then D equal to sine theta R plus H, because sine theta equal to D by R plus H. Cos theta equal to R by R plus H. So sine theta equal to D by R plus H. So D distance is sine theta into R plus H, and theta equal to cos inverse R by R plus H. Then R theta equal to R cos inverse R by R plus H, means S equal to R into cos inverse R by R plus H. Same thing we are saying. So the arc, okay, so person, so if this is a cross section of earth and person is standing like this, if this is the radius of the earth and this is the height of the person is looking down, looking down, then this is the d distance he is seeing. This earth curvature is S. Then this is again R. This is theta. This is theta. Now, if that is the case, then idea is that this S, the curve, the arc, and D should not be the same. If they are same, if person is just standing on the earth and he is seeing far away, that he whatever maximum he can see, the earth curve, the arc, and his distance would be similar, because 4 or 5 kilometer earth cannot be round. But when earth is becoming round, then his eye distance hitting the earth and earth curve arc would not be same. What angle it would not be the same? That we have, as per the promise, we have calculated. So the D is sine theta into R plus H, and S equal to R into cos inverse R by R plus H. So if person is standing on Mount Everest, then okay, leave it. Okay, so what, as per the calculation, if theta is 45 degree, if this theta is 45 degree, then S and D, so if theta is 45 degree, then S is 5010 kilometer, whereas D is 5429 kilometer. So they are different. So 45 degree, if person is seeing so far that from center of the earth it is making 45 degree, certainly he can see the curvature. What about 10 degree? Then S, the the S, that is the arc, that is 1112 kilometer, whereas the D is 1107 kilometer. So again it is different at 10 degree angle also. Anyway, now we have equation for the distance as per the h. So distance equal to square root of h square, a square root of r plus h whole square minus r square, as per the Pythagoras theorem. Then it resolves into h square plus 2rh. H square is gone because it is so small, the 2 into r into h square root, or if someone takes h square also. If someone calculates for different h, then if it is kind of, it is if it is 1 meter, h is 1 meter, then visibility he can see is, I'm sorry, okay, in feet. If person is 5 feet tall, then he can see 2.7 miles away. If it is 10 feet tall, he can see 3.8 miles away, as per the d equal to square root of h square plus 2r into h, where r is the radius of earth, that is 6000, radius of the earth is 6378 kilometer. Okay, and h in feet, if I do with this calculation, then there is a data 10 feet. If person is height is 10 feet, then he can see 3.8 miles. Like that, if it is 100 feet high, then he can see 12 miles. If it is 1000 feet high, then he can see 3.8 miles. If he is 100,000 feet high, then he can see 387 miles. Okay, anyway, what about Mount Everest. If person is standing on the Mount Everest, then it is 29,000 feet height or 8,848 meter height. If that is the case, then person can see, as per the formula, person can see 335 kilometers. D, a person is standing on Mount Everest when he is seeing the Earth's surface, the D distance is 335 kilometers. What about S? That is the curve or arc of the Earth. That is also 335 kilometers. Exactly same. As per the formula, D equal to sine theta R plus H and S equal to R cos inverse R by R plus H. Whatever formula we use, same diagram we are using. But then it goes till 335 kilometers and it makes around 3.01 degree from the center. It makes 3.01 degree. Now we are in calculation for at what degree this D and this earth arc would be separate, different. So at Mount Everest it is same, but beyond Mount Everest, like 10 degree, it is different. Beyond Mount Everest, 3 degree onwards, it is different. So person standing on the Mount Everest with his height 8,848 meter, he can see earth curvature, but anything below that height, he cannot see the earth curvature. So only, and the atmosphere is completely clean in Tibet plateau region. It is flat. Tibet plateau is flat, and person at standing on Mount Everest, then he is seeing the flat Tibet region from 8,848 meter high. At that moment, he is able to see 335 kilometer north towards Mongolia in the Tibetan plateau, flat plateau, and that makes 3-degree angle with the 3.01 or 3.011 degree angle with the center of the earth. Okay, in that case, theoretically he should see the curvature. Practically, we have photograph. So practically, he can see the curvature. So curvature of Earth is possible on Earth only from the Mount Everest, not anything below it, because there are two reasons. One is height to a level where he can see the curvature. The second thing is northern part is Tibetan plateau and it is very clean, so he can see the. So a person standing on Mount Everest can really see the Earth curvature. So that is possible on Earth. But roundness of the Earth, anyone can prove that Earth is round if he stand on Mount Everest and see the northern side, 350 kilometer around, he can see. So go and climb Mount Everest and prove Earth is not flat, it is round.